All right, today we're going to talk about the area of a couple different shapes, rhombus and kite. Rhombus, we need to remember that it is actually also a parallelogram. So remembering our properties from earlier in the year, and then also it will share the same formula with a kite, and then also the area of a trapezoid. So we're going to start first with a trapezoid. Trapezoid, we have two bases, base 1 and base 2, base on the top and the bottom. We also have the height, which makes a right angle with the bases. So the area of the trapezoid is half of the bases added together multiplied by the height, or it is also done as the median times the height, and the median is the segment that is in between the two bases. The median is always just equal to half of the bases. So it doesn't really matter which one, but you could use two different formulas for the trapezoid. So in number one, first off, to find the area. Half of our bases added together multiplied by our height. So we have base 1 and base 2. So half of 11 and 15. Multiply that by our height of 18. So half of 26 times 18, and we're going to get 234 units squared. And then the median, remembering that that is the segment that is in the middle of the two bases. So in the middle of 11 and 15 would give us a median length of 13 units. For number 2, it tells us the area, so we need to just start off with our formula area equals, but in this case, since it says find median, I'm going to use the formula for the trapezoid. That is area equals median times height. Then I'm going to substitute in everything I have. I have the area is 96. I don't know the median, so I'm going to keep it in as m. And the altitude or the height, it's the same thing, is 6. So we have an equation of 96 equals 6m. Divide both sides by 6, and we get a median of 16. Same concept here for trapezoid. We're given the area. So we're going to, because we're talking about both bases, we're going to look at the other formula. So area equals 1/2 base 1 plus base 2 times height. Plug in everything that you have here. We have the area is 997.5. 1/2. Base 1 is x. Base 2 is 40. And then my height is 21. Now, first thing I'm going to do is half of 21 is 10.5. So multiply those two together. And then I am going to divide by 10.5. I'm going to get 95 equals 40 plus x. So x equals 55, and we are talking about centimeters. For number 4, we're just talking about two separate trapezoids. So first off, remember the formula again. Half of base 1 plus base 2 times the height. It tells us that the height of each of these trapezoids is 5. So 5 and 5. So first off, to do this top one, half of 10 and 16 times 5. And then the bottom one is half of 4 and 16 times 5. On the top, we get an area of 65, and on the bottom, we get an area of 50, and together that gives me an area of 115 units squared. Next, we're going to talk about kites and rhombi. First off, the rhombus, we know one of the formulas for the area of a rhombus because it is, as I said before, it is a parallelogram. So we're going to do base times height, remembering that the base and the height have to meet at a right angle. And then the other formula which will be used for both of these is 1/2 of diagonal 1 times diagonal 2. So however long the diagonals are, we multiply them together and divide by 2. So that is also going to be true for a rhombus. For number 5, find the area of a rhombus if the diagonals are 30 and 40. So just use the formula of half of d1, d2. So it's half of 30 times 40. And I'm going to get an area of 600. Now, where these rhombus ones, the most complicated they can typically be is if I was to also ask the question is what is the height? So now I still would have started the same way. I still need that 600 units squared is how I started. Then I need to remember my rhombus properties. If it's 30, that means it breaks up into 15 and 15 because they bisect each other. And if it's 40, it breaks up into 20 and 20. I can use the Pythagorean theorem, which is a triple, and recognize that it's 15, 20, and then my other side would be 25. Now I would need to know my other formula for area, which is base times height. The area is still 600, but it equals base times height now. I have my base of 25, solve for my height, and I would get a height of 24 units. So this would be if I was to add in a question of what is the height. For number 6, find the area of this kite. Again, half of d1, d2. One of the diagonals is bisected. It's clearly not that one. So we have 3. This other one would be 3. Half of one diagonal is 8. The other diagonal is 6. So I'm going to get 24 units squared. Here is number 7 is similar to how I said number 5. We want to find the area and then the height. So first off, use the fact that the perimeter is 52. So understanding our rhombus has all of the sides are the same. So 52 divided by 4 tells me that every side is 13 units long. Then apply the next part, which is a diagonal of 24, which means it's going to break up into 12 and 12. I can now use my Pythagorean theorem for one of my triangles here and find out that that is if we remember our triples, if you don't, you can do Pythagorean theorem, but if you do, that is a 5, 12, 13, which means the other half is also 5. I now have enough information to find the area because I can use my 1/2 diagonal 1 times diagonal 2. One of my diagonals totals 10. The other one totals 24, which gives me an area of 120. Then I'm going to find the height of the rhombus. By using the other formula, base times height. The base is 13 here. So my height is going to be 120 divided by 13. Find the measure of the side if a rhombus has a diagonal of 48. So I would need to find the other diagonal. So 768 is half of diagonal 1, diagonal 2. Plug in my 48 for the one diagonal, and I can solve for the other diagonal. When I solve for that diagonal, I get 32. Then I'm going to use my rhombus properties of bisecting that, and I get 16 and 16. And then in order to find the side, I can use right angle, Pythagorean theorem, and I would get 24 squared plus 16 squared equals the side squared. And when I simplify that, I will get 8 root 13. Rhombus has a 120-degree angle, and its longer diagonal is 12. If this is 120, the other angle has to be 60, which means 12 must be across from the 120-degree angle. So when I bisect this, I get 6 and 6. And this is a 60-degree angle, and this is a 30-degree angle. So now this is going to bring in our 30, 60, 90 knowledge within this triangle right here of a 30, 60, 90. Remembering that in my 30, 60, 90 triangles, it is A root 3, and 2A. And if across from 60 is 6, then that's my A root 3 value. So A is 2 root 3, which means my other side is 4 root 3. So I get 4 root 3 there, 2 root 3 there. So for my area formula, remembering that it's 1/2 of D1, D2. One diagonal is 12, and the other diagonal is 4 root 3. When I multiply that together, I get 24 root 3 units squared. So remember, we talked about rhombus, remembering that a rhombus is both of those formulas, and a kite is that formula. And then also talked about trapezoids using those formulas. Make sure you know those formulas, and that is the end of today's notes.